Chapter 10, Section 3 is combinations. A selection of objects without regard to order is called a combination. So remember in Section 2 we talked about permutations, and in permutations the order mattered. In combination, the order does not matter. So let's talk about our friends Mary, Jim, and Bob again. And this time I want to write down all the permutations of two of the three friends. So remember, in permutations, order matters. So I could have Mary and Jim hanging out, or Jim and Mary, and these are different permutations. Or maybe we're talking about Mary and Bob, or Bob and Mary, different permutations. And lastly, we can have Jim and Bob, or Bob and Jim, which are different permutations. For combinations, if I have the same two people in a group, I don't care what order they stand in, they're the same combination of people. So the only combinations I'm going to have are Mary and Jim, Mary and Bob, or Jim and Bob. So while there are 6 permutations, there are only 3 combinations. Exercise 1. Identify the following as a permutation or a combination. Why don't you try this on your own? Pause the video and guess if you think part A is a combination or a permutation, and then if part B is a combination or a permutation. Part A says a 4-digit passcode is chosen from the numbers 0 through 9. Well, if I was making up a passcode, let's say for your phone, I would think that the code 1258 is different from the code 8251. So the order matters. So for part A, this would be a permutation. Part B says a chef picks 3 vegetables out of 6 choices to put in his vegetable soup. Okay, if you have a soup and it has carrots, onion, and celery, is that different from a soup that has onions, celery, and carrots? I don't think so. I think if you have the same 3 vegetables in your soup, they're still the same 3 vegetables regardless of what order you throw them into the pot. So in this case, the order does not matter. Making this a combination. The combination rule. The number of combinations of n objects taken r at a time without replacement is denoted by NCR. Looks familiar, looks like our NPR with permutations. NCR is equal to NPR divided by r factorial. Or if we write out the whole formula, n factorial divided by n minus r factorial times r factorial. Just like I said for NPR, I would say N pick R. For NCR, I'm going to say N choose R. Exercise 2. A piano instructor posts a list of 8 pieces to her website. Every student is required to learn and perform 4 of the 8 pieces at some point during the semester. How many different ways can a student choose the 4 pieces they want to perform? Okay, if I'm going to choose 4 pieces to play, it doesn't matter what order I choose to learn and perform these pieces, it just matters what 4 pieces I chose. So this is a combination problem. And out of the 8 choices, I need to choose 4 of them. Plugging that into our formula, I have 8 8PR, or 8P4, divided by r factorial, which is 4 factorial. Plugging that into our formula further, I'm going to have 8 factorial divided by 8 minus 4 factorial times 4 factorial. I can use our trick where I write this out a little bit. In the denominator, I have 4 factorial times 4 factorial. One of those will simplify away. I'm left with 8 times 7 times 6 times 5 divided by 4 factorial. Let's plug that into our calculator. I can do 8 times 7 times 6 times 5 divided by 4 factorial, and I get 70. So this implies there are 70 different ways that a student can choose 4 of the 8 pieces. Exercise 3. Becky is making candy gift bags for her daughter's birthday party. She wants to pick 6 pieces of candy from a selection of 9 chocolate bars and 6 fruit-flavored candies. How many possible choices for the mix of candy are there if she wants to have at least 4 types of chocolate bars in each bag? Okay, so there's 9 different chocolate bars she can pick from and 6 different fruit-flavored candies she can pick from. All we know for sure is she wants to have 6 pieces of candy, and 4 of them should be chocolate bars. At least 4 of them. So the options are that maybe she has 4 chocolate bars and 2 fruity candies. Now it says at least 4, so maybe she has 5 chocolate bars and only 1 fruity candy. Or she has 6 chocolate bars and no fruity candy. Those seem to be the 3 options for how this gift bag is going to be filled. Now, the order in which the candy goes into the bag is not important, right? So we're dealing with combinations. How many different ways can I choose 4 chocolate bars out of 9 chocolate bars? Well, we have a formula for that. I can do 9 choose 4. And how many different ways can I pick 2 fruity candies out of 6 fruit-flavored candies? Well, again, I can do 6 choose 2. And then using my fundamental counting principle, whatever this number is will be the number of ways that my first item can occur. And whatever this number is will be the number of ways my second item can occur. My fundamental counting principle tells me if I multiply these together, it'll give me the total possible number of ways that this scenario can occur. Using the same logic, I'll fill out the next 2. So for 5 chocolate bars, out of my 9, I'm choosing 5. And out of my 6 fruit-flavored candies, I'm choosing 1. And lastly, out of my 9 chocolate bars, I'm choosing 6. And out of my 6 fruit-flavored candies, I'm choosing 0. We can plug this into our calculator. There's actually a button for this, so if we go back to Desmos, you'll see I have this button that says NCR. Well, this is where I can plug in for my combination. So in here, I'm doing 9 choose 4, which is 126. If you're using the calculator you have in class, that looks like this. It's also inside this probability button, just like the factorial was. So if you push the probability button, you'll see, I think it's like a capital P and a capital C. No, it actually says NPR and NCR. So you can scroll over using the arrow, and that'll allow you to choose the NCR. So what you would do is you would type in your number first. So type in 9, hit probability, scroll over to NCR, and then hit 4, and then hit enter. And that will give you your combination for 9 choose 4. And you can do the same thing using the NPR And you can do it for all of your different problems that involve these two operations. Going back to our document, we saw that 9 choose 4 was 126. If you use your calculator, you'll see that 6 choose 2 is 15. And when I multiply these, I get 1,890. Doing the math for the rest of them, you get 756 and 84. Well, these three numbers are the total number of ways that I can have a gift bag with the 4 chocolate bars and the 2 fruity candies, the total number of ways I can have a gift bag with the 5 chocolate bars and the 1 fruity candy, and the total number of ways that I can have a chocolate bar with a gift bag with 6 chocolate bars and no fruity candy. So the total number of ways that I can make gift bags that have at least 4 types of chocolate bars in them are going to be, when I add all of these together, or 2,730 different ways or different choices.